Hello everyone. In this video I will work exercises to review for quiz 2. So in the first problem we are asked to perform the difference between two complex numbers. Recall that I is the imaginary number defined as the square root of -1. So we have 2 minus 3i minus 5 plus 4i. Recall that when we subtract complex numbers, we're going to combine like terms. So we're going to combine the constant numbers together and the imaginary numbers together. So we're going to have 2 minus 3i, subtract 5, so minus 5 minus 4i. So what I did here is I distributed the negative into the 5 into the 4i. Then combine like terms, we have 2 minus 5, which is -3, and then negative 3i minus 4i is negative 7i. In the next exercise, we're asked to factor this quadratic expression. There are a few methods on how to factor a quadratic expression. Here I will use the trial and error method. Which is also called guessing method. In this method, we pay attention to the coefficients of our quadratic expression. We know that the first term is going to be the product of the two terms of the binomials. So we're looking at writing this as a product of two binomials. And in the first terms, we're going to break down s squared as s and s. And then the second terms of the binomials will be factors of 7. So let's look at how we can factor 7. And it's a positive 7. So we can factor it as 7 and 1, or -7 and -1. We're looking for the pair that multiplies to 7 and adds up to -8. So in this case, because we have a -8, we're going to pick up -7 and -1. So the answer is s minus 7 times s minus 1. So let's check this real quick. So s minus 7 times s minus 1. So we're checking. S times s is s squared. So distribute s into s and s into -1. So minus s. And then -7 times s. So minus 7s. -7 into -1, so plus 7, which will give us s squared minus 8s plus 7, which is the same as the quadratic expression we started with. So the answer is s minus 7 times s minus 1. We're asked to factor in this example, and we have 1, 2, 3, 4 terms. And the first thing we're going to look at is see if we have a greatest common factor for all terms. So what we're going to do is we're going to group the first two terms and the last two terms. That's why this is called factor by grouping. So we're going to find the greatest common factor for the first two terms. So between 9 and 81, we have 9 And between a to the third and a squared, we have a squared. And then we're going to multiply this by the quantity of a. How did I find a? 9a to the third divided by 9a squared is a. And then plus 81 divided by 9 is 9. And a squared divided by a squared is 1. So 9a squared times the quantity a plus 9 is 9a to the third plus 81a squared. And then we're going to factor the greatest common factor for the last two terms. Between 5a and 45, we have 5 to be the greatest common factor. Then we're left with a plus 9. All right, we're noticing here that we have two terms. Here's term 1 plus the next term. And in each of these terms, notice that a plus 9 is a factor. A plus 9, a plus 9. So we pull that out. So we're factoring out a plus 9, then we'll see what we're left with. So once we take the a plus 9 out, we're left with 9a squared plus 5. So that's the answer. Okay, so here we are dividing two complex numbers. So we want to rewrite the quotient as a standard form of a plus bi. So what we're going to do is we're going to multiply the numerator and the denominator by the conjugate. The conjugate of a plus bi is a minus bi. Okay, so the conjugate of 5 minus I is 5 plus I. So we're going to multiply the numerator and the denominator by 5 plus I. So let's make sure we put 5 minus I in parentheses, because we're going to multiply it by 5 plus I and multiply the numerator by 5 plus I. Then we're going to simplify. In the numerator, we're going to distribute the negative I. So we have negative 5i minus I squared. And on the denominator, we have 25 minus 5i plus 5i minus I squared equals negative 5i minus, recall that I squared is negative 1. So instead of I squared in the numerator now, I'm going to have minus negative 1. And in the denominator, negative 5i and plus 5i will cancel out. So we're left with 25 minus I squared is negative 1. So simplify further, we have negative 5i plus 1, and the denominator 25 plus 1. Let's rewrite this in the order of having the real part of the complex number first, which is 1, and then minus 5i divided by 26. Now remember, we need it in the form a plus bi, so we're going to split this. 1 over 26 minus 5 over 26 times I. So the real part of this complex number is 1 over 26, and the imaginary part is negative 5 over 26. In this example, we're asked to find the domain of this rational function. Recall that the domain is the set of all real numbers for which we can calculate the expression. The expression makes sense. So when we divide numbers, we are going to make sure that we cannot divide by 0. So we cannot have 3 divided by 0. This operation cannot be done. 5 divided by 0 cannot be done. So when we're looking at the denominator, we want the denominator not to be 0. So we're going to exclude real numbers that give a 0 in the denominator. So in order to do that, and the first step is we're going to find those numbers that will make the denominator equal to 0. So in the first step, we set the denominator equal to 0. In order to find those numbers that will make the denominator equal to 0. So we have x minus 9 times x plus 3 equals 0, from which we get x equals 9 and x equals negative 3. So the domain is all real numbers except x equals 9 and x equals negative 3. So domain, I'm going to write this in set notation. Domain is all numbers x from R such that x is different from 9 and x is different from negative 3. In interval notation, we're going to have all real numbers, negative infinity to negative 3, union negative 3 to 9, union 9 to infinity. So this is where we exclude negative 3 and 9. In this example, we're asked to factor the difference of two cubes. Well, there are various methods of factoring. The quickest way of factoring the difference of two cubes is to remember the formula. If we have a to the third minus b to the third, this is a minus b times a squared plus ab plus b squared. So in our case, a is w and b is t. So that being said, w to the third minus t to the third is equal to a minus b. So a is w minus b and b is t times a squared, which is w squared, plus ab, w times t, plus b squared, which is t squared. Here we have another quadratic expression. Let's do this by guessing method. So we're going to write this as a product of two binomials. Remember, binomials means two terms. So we're going to break down s squared as s and s. Because the constant term is negative, we're going to have 1 minus and 1 plus, because we're going to look at factors that multiply to negative 20 and add up to negative 8. So let's break down negative 20. Negative 20 is plus or minus 1 times plus or minus 20. It actually has to be in opposite way. Minus plus. So if we have 1, we're going to have negative 20. Negative 1, we're going to have positive 20. Either plus or minus 4 times minus or plus 5. Another way of breaking down negative 20 as a product of two numbers is 2 and 10. 2 times 10 is 20. So we're going to have plus or minus 2 or minus and plus 10. So 1 and 20 is not going to give us negative 8. 5 and 4 is either going to give us a negative 1 or a positive 1. So that's not going to work. So if we take 2 and 10, if we take negative 10 plus 2 equals negative 8. So negative 10 and positive 2 are the two numbers we're looking for. So then we have s minus 10 and then s plus 2. Let's check this real quick. S times s is s squared plus 2s minus 10s minus 20 equals s squared minus 8s minus 20. So notice that the product of the two binomials is the same as what we started with, so then our answer is correct. I always like to check when I factor, make sure that I factor correctly. Okay, find the product. We use a distributive property. So we're going to multiply each pair of two terms. So I always start with the first one. So 7x, I'm going to distribute 7x into 49x squared, and then 7x into 28x, and 7x into 16. Okay, so 7 times 49 is 343. X times x squared is x to the third. So 7x times 49x squared is 343x to the third. Plus 7x times 28x. 7 times 28, 196x squared plus 7x times 16. 7 times 16, 112x. And then we're going to distribute the negative 4 into 49x squared, and then into 28x, and then into 16. So 4 times 49x squared, 4 times 49, 196, because I'm going to have x squared, I'm going to put this below the x squared term I got before. Just to see that I can combine like terms here. Negative 4 times 28x, 4 times 28, minus 112 x minus 4 times 16, 64. Okay, so now we're going to combine like terms. We have only one term with x to the third power, so we bring that as is. And then the x squared terms will cancel out, and the x term will cancel out, minus 64. Recognize here that this is a difference of two cubes situation. 343 is 7 to the third, and 64 is 4 to the third. In this exercise, we're asked to find the product of 1/5 minus I and its conjugate. So the conjugate of 1/5 minus I is 1/5 plus I. So conjugate of 1/5 minus I is 1/5 plus I. So now we're going to multiply. Product is multiplication operation. 1/5 minus I times 1/5 plus I equals 1/5 times 1/5 is 1/5 squared plus 1/5 times I, multiply 1/5 times I, and then we're going to distribute negative I into 1/5 minus 1/5 I, and then negative I into I minus I squared equals 1/5 as a quantity squared is 1/5 squared, which is 25. So 1/25. 1/5 I minus 1/5 I will give us 0. So then we're left with minus I squared. And recognize that I squared equals negative 1. So we have 1/25 minus negative 1, which is the same as 1/25 plus 1. And if you add these two fractions, you get 26/25. We're asked to simplify in this exercise. Well, it looks like we're subtracting two fractions. When we subtract fractions, we need same denominator. So the first thing that we need to do is find the least common denominator. The least common denominator is the least common multiple. So between x minus 2 and x plus 2 is x minus 2 times x plus 2. So we're going to convert both fractions with the same denominator. So I'm going to rewrite this. So we're starting with x plus 3 over x minus 2. And we need to make the denominator x minus 2 times x plus 2. So that means we're going to multiply the denominator by x plus 2. Once we multiply the denominator, we got to multiply the numerator by the same number, x plus 2, minus x plus 4 over x plus 2. So we're going to compare the second denominator to the common denominator. That means that we're going to be multiplying by x minus 2, both numerator and denominator. We're going to combine both fractions because now they have the same denominator. X minus 2 times x plus 2. Simplify each of the numerators. So x plus 3 times x plus 2. And I'm going to let you work this out. This is x squared plus 5x plus 6. Just distribute. X squared plus 5x plus 6 minus, and then we're going to distribute x plus 4 times x minus 2. That's going to give us x squared plus 2x minus 8. Make sure you multiply this step by step. Since I'm subtracting, I'm going to put the second quadratic expression in parentheses so I don't mess up my negative signs. X squared plus 2x minus 8. So bring over the denominator, and the numerator we're going to have x squared plus 5x plus 6. Then I'm going to distribute the negative into each of the terms of my second quadratic expression. So minus x squared minus 2x plus 8 equals, again, denominator is the same, x minus 2 times x plus 2, just carry it over, and then combine like terms in the numerator. X squared minus x squared will give us 0. 5x minus 2x is 3x. 6 plus 8 is 14. Okay, so we simplified it. Okay, so this is a geometry problem. A triangle has an area x squared plus x minus 72. So this is the quantity that gives us the area of the triangle measured in square meters. And we're given the base length, x minus 8 square meters. We're asked to find the height. All right, so we know that the area of the triangle equals base times height divided by 2. Since we're asked to find the height, we can solve this equation for height. Multiply both sides by 2, so we have 2a equals b times h. To get to h, we divide by b, divide by b. Therefore, h equals 2a over b. H is what we want to find. A is given. A is given. and B is given. Okay, so let's plug in our data into the equation. We want H equals 2 times A. A is x squared plus x minus 72. B is x minus 8. Okay, so let's try to factor the numerator. Let's bring over a denominator, which is x minus 8, and we have the 2. We're going to factor x squared plus x minus 72 by using trial and error like we've done before. So we're going to break down x squared as x and x, because x times x is x squared. Then we're looking at factors of negative 72 that add up to x. Well, because we have negative 72, we're going to have 1 plus and 1 minus. Let's look at the factors of negative 72. Well, what I'm thinking of is 9 and 8. 9 times 8 is 72. And if I have 9 times negative 8, that will give me negative 72. And 9 minus 8 is 1. And that's what I need because the middle term is 1. I have 1 in front of x. So x plus 9 times x minus 8. That's good. We have x minus 8 in the numerator and denominator. We can cancel that. So the answer is 2 times x plus 9. I've got to make sure now that x has to be different from 8. Because the height the base cannot be 0. If x is 8, then it will give us the base of a triangle to be 0, and we can have that. So our final answer is the height for this triangle is 2 times x plus 9 meters. I saw an error here. The base